Okay, here we go. Step one of the central dogma, which is DNA to RNA. So oops, I get a pencil here. DNA to, I should say, mRNA. This is step one. Okay, so let's go ahead and take a peek at this here real quickly, Here's our DNA. Okay, blah, 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 blah. Okay, and what's going to happen is you have an enzyme called, it's a big protein enzyme called RNA polymerase. Okay, and this is an enzyme that's going to zip down the DNA from the start of a gene to the end of a gene. Okay, so remember we said a gene was any length of DNA, whether short or long. It's going to find a place that says start and a place that says stop, and it's going to zip down this big protein enzyme called RNA polymerase and read the DNA. Okay, it's going to read the DNA. Now there are two strands of DNA. Okay, remember it's a double helix. One strand is going to be, for example, it's going to be the sense. And the other strand is going to be the antisense. All right, and here's an important test question. The antisense is also called the template. So it's interestingly enough that the one that makes sense is not the one we use. We use its opposite, the antisense strand. Okay, and so what happens is it unzips DNA, okay, and I will show you that here. So here's DNA, and I'll bring it together down here, and we'll say A, T, C, G, okay, all that kind of stuff, and then it's G, C, G, T, A, and then T, T, A, C, G, and here we have, remember, the hydrogen bonding, but now these have been unzipped. Okay, it's been unzipped, and here is our RNA polymerase, okay, buzzing down, okay, the antisense strand, okay, buzzing down the antisense strand, okay, and it is complementing this, okay, and let's say, what is it doing? It is making a molecule called mRNA. And here it is. As it's going through, G pairs with C. C pairs with G. A pairs with U. We no longer have T's in RNA. T pairs with A. T pairs with A. And so on as it goes through. Okay, so this is the deal. It's going to use the antisense strand as its template that it's going to run along and complement and make a molecule called mRNA. Okay, mRNA. Let's go to the next slide. What is the difference between DNA is double-stranded? It also has thymine. Okay, RNA, whether it's mRNA or whatever, is single-stranded. It'd also be smaller, and it has uracil in place of thymine. Okay, so that's very important to know. All right, so in this particular sense here, the RNA polymerase will buzz down, and again we'll describe it. So here's our DNA. Okay, here's our unzipped DNA. Here is our RNA polymerase that has moving down this way, and as it goes down, okay, it's creating this strand of mRNA. Okay, it's single-stranded, and it's the complement of the antisense strand. So notice what's happening. This may be bizarre to get, but here you go. You have to try to do this now. It's very complicated. Since it is complementing and pairing with the antisense strand, it's going to be an almost exact copy of the sense strand. So it's like the antisense of anti-sense equals sense. Okay, so it's like the negative of the negative is a positive. So it uses the anti-sense strand as the template. It complements it, which makes it look just like the other side, which is the sense. So in essence, this is the way it works. It's a subtlety. It's difficult to get your head around, but think about it and it will make sense. Okay, so this is step one, differences between DNA and RNA, and DNA is going to mRNA. Okay, and that's the first step in the central dogma. This is called transcription, and it happens in the nucleus. Okay, remember that, transcription, and happens in the nucleus.